This problem is related with the dimensional analysis in quantum scattering. So, in scattering of some elementary parting, the scattering cross-section area is found to be dependent on total energy in a fundamental constant H and C, where H is Planck constant and C is speed of light. Using dimensional analysis, the dependence of sigma on these quantities is given by. So, let us write it out the dimensions. H has dimension of energy E and T. C has dimension of L into T inverse 1, and sigma has dimension of L square. Now select option C, lattice HC by E, T. Option C, SC by E square equals to mod E dimension of T into LT minus 1 divided by dimension of E square equals to dimension of L square equals to sigma square. Thus, our option C is giving correct dimension of scattering cross section. A Hermitian operator O has two normalized eigenstates 1 and 2 with eigenvalue 1 and 2 respectively. The two states U cos theta 1 plus sin theta 2 and V cos phi 1 and sin phi 2 are such that U, V expectation value of V O with state V is 7 by 4 and UV equals to 0. Which of the following are possible values of theta and phi? So we have to determine the following values. Now question has said we have solution. Let us write it down the solution. We have state U equals to cos theta 1 plus sin theta 2, and state V we have cos phi 1 plus sin phi 2. Now U and V are orthogonal. Form condition to 0. So equals to cos theta 1 plus sin theta 2 into cos phi 1 plus sin phi straight 2 equals to cos theta cos phi plus sin theta sin phi is equals to cos theta cos phi plus sin theta sin phi equals to cos theta minus phi is equals to 0, implies theta minus phi equals to pi by 2. So let us check it which option are giving us phi minus theta equals to pi by 2. So if we check it out, option phi minus theta is equals to pi by 2. That means pi by 3 minus pi by 6 to pi by 3 plus pi by 6 equals to pi by 2. That means option A and option D. Option A and D, that is phi is equals to pi by 3 and theta is equals to minus pi by 6, satisfied above condition. Now here this term should be positive, otherwise both these options should be same. That means first and fourth, phi pi by 4 minus theta. Second option C, phi is equals to pi by 4 and theta is equals to minus pi by 4, satisfies. Now expectation value O is operating on V is equals to O cos phi state 1 plus sin phi state 2 equals to cos phi 1 plus 2 sin phi 2. Now expectation value to cos square phi plus 2 sin square phi 2 by 2 equals to O cap cut through V, O cap V equals to cos square phi plus 2 sin square phi equals to 7 by 4. Now we have two values of phi, that is phi is equals to pi by 3 and phi is equals to pi by 4. However, for phi is equals to pi by 3, cos square pi by 3 plus 2 sin square pi by 3 is equals to 1 by 4 plus 2 into 3 by 4 equals to 7 by 4. Thus, our option A is correct answer. The ground state energy of a particle of mass m in the potential Vx V0 cos hyperbolic x by L, where L and V0 are constant, is approximately. So, we have to determine the ground state energy. Solution: we have V of x is equals to V0 cos hyperbolic x by L. Expanding cos hyperbolic x by L, we get cos hyperbolic x by L equals to plus 1 by 2 x square L square. Substitute. Thus, our potential Vx takes the form Vx is equals to V0 1 plus x square by 2L square. V0 plus 1 by 2 V0 L square into x square equals to V0 plus half kx square. Here we have neglected higher term. And here we have used k is equals to m omega square is equals to V0 by L square, implies omega is equals to root over V0 by m L square. So energy associated with the potential given in equation 1 is given by E is equals to V0 plus half h cross omega, that means V0 plus h cross by 2 is V0 by ml square. So our option D is correct. This question is from hydrogen atom. In this question, psi nm denotes the eigenstate of hydrogen atom in usual notation. The state psi is defined as 1 by root 5 2 psi to 0 3 psi to 1 plus root 7 to 1 0 root 5 psi to 1. If we check it psi dot psi, you will find it out. It is normalized 4 by 25 plus 9 by 25 plus 7 by 25 plus 5 by 25. So that is normalized. Now the question is asking the state is an eigenstate of which of the term. Solution: I am writing 3 statements on the basis of which we can solve such type of problem. For wave function and LM, psi and LM. First, for psi and LM is an eigenfunction of Hamiltonian if all the states in the psi and LM has same value of n. Second, psi and LM is an eigenstate of L square if all the eigenstate corresponds to same L. Third, psi and LM is an eigenstate of Lz, z component of angular momentum, if all the eigenstates in the psi and LM correspond to same ml. So let us check it. Now n N is 2. So N is 2, that means it is an eigenstate of H, Hamiltonian. Now L is 0, 1, 1. So L takes value 0, 1. So it cannot be eigenstates of L square. Now ML 0, 1, 0, minus 1. So ML takes value 0 plus minus 1. That means psi and LM is not an eigenstate of LZ as well. That means our option B is correct. The Hamiltonian Fourier spin half particle at rest is given by where sigma x and sigma z are Pauli spin matrix and E0 and alpha are constant. The eigenvalue of this Hamiltonian are. So we have H is equals to E0 sigma z plus alpha sigma x is written at E0 1 alpha alpha minus 1, where we have used sigma z is equals to 1 0 0 minus 1, sigma x is equals to 0 1 1 0. The eigenvalue are obtained from circular equation or H minus lambda I equals to A0 alpha minus lambda alpha A0 into alpha A0 minus A0 minus lambda equals to 0 implies minus A0 plus lambda into A0 minus lambda minus alpha square A0 square equals to 0, or we can write it down lambda square minus A0 square minus alpha square A0 square equals to 0, or lambda square is equals to A0 square 1 plus alpha square implies lambda is equals to plus minus A0 root over 1 plus alpha square. So our option A is correct for this problem. This problem is related to the perturbation. So in this problem, a hydrogen atom is subjected to the perturbation potential, where N0 is Bohr radius. The change in ground state energy to the first order in epsilon is. So we have to determine correct first order correction in ground state energy. Solution. The eigenfunction and eigenvalue of an electron in H atom is psi of r equals to pi A0 cube e to the power minus r by A0 En is equals to minus r infinity hc by n square. The perturbed potential is given by HP is equals to epsilon cos 2R by A0. The correction in the ground state energy is given by EG1 equals to N H dash N equals to epsilon pi A0 cube e to the power minus 2R by A cos 2R by A into 4 pi R square dr, which is equals to minus epsilon by 4, where we have used 0 to infinity R square cos 2R by A0 e to the power minus 2R by A0 2R by A0 dr equals to minus A cube by 16. Thus our option D is correct. A positron is suddenly absorbed by the nucleus of a tritium atom to turn the latter into helium ion. If the electron in the tritium atom was initially in the ground state, the probability that the resulting He ion will be in its ground state is. So, this problem is from sudden approximation perturbation. The sudden approximation method is used to solve this problem. Further, the wave function corresponding to helium and helium ion and tritium atom are. So psi He positive is equals to 2 by A0 के power 1 by 2 e की power minus 2 R by A0 divided by root 4 pi psi TR equals to 2 by A0 1 by 2 into e की power minus R by A into root 4 pi. If the electron in the tritium atom was initially in the ground state, the probability that the resulting helium ion will be in its ground state is P is equal to mod psi E He plus psi T mod square is to 1 by A0 cube 2 की power 3 by 2 1 by 4 pi e की power minus 3r by A0 r square dr 0 to pi 0 to 2 pi sin theta d theta d phi square is equals to 2 9 by 2 27 square that is equals to 512 by 729. Thus, option D is correct for this problem. This problem is related with the variational principle. Here, the ground state energy of a particle in potential Vx is equals to G mod x. Using the trial wave function, we have to determine the energy. Solution. We have psi x is equals to c a to power 5 a square minus x square for x less than mod a. Let us determine the value of c. Normalization constant c is determined as follows. That is psi not psi equals to minus a to a c a square minus x square a to the power 5 dx is equals to 16 c by 15 equals to 1 implies c is equals to 15 by 16. Thus, the normalized wave function is psi of x is equals to root 15 by 16 a to the power 5 a square minus x square. The Hamiltonian for the system given by h is equals to minus h square by twice m del square by del x square plus g mod x. The energy for this Hamiltonian is given by E of A is equals to psi of x h psi of x equals equals to psi of x minus h square by twice m del square by del x square plus g mod x psi x is equals to minus h square by twice m psi of x into del square psi by del x square plus g of psi x mod x into psi of x equals to a. Now determining value of first inner product. We have psi del square psi by del x square equals to 15 by 16 a की power 5 minus a to a square minus x square del square by del x square a square minus x square dx equals to 15 by 16 a to the power 5 2 minus 2 0 to a square minus x square dx equals to minus 15 by 4 a की power 5 a square x minus a cube by 3 x cube by 0 to a equals to minus 5 by 2 a square. Similarly, the value of second inner product is a x a की power 4 plus x की power 4 minus 2a square x square dx is equals to 15 by 8 a की power 5 x square by 2 a to the power 4 plus x की power 6 by 6 minus 2a square x की power 4 by 4 0 to a equals to 5a by 16. Substituting the value of inner product in the expression of energy, we get E of A is equals to 5h square by 4ma square plus 5ga by 16. Further, we have to differentiate energy with respect to A equals to minus 5 by 4 h cross square by m a cube 2 plus 5 by 16 g equals to 0 implies a is equals to 2 h cross mg की power 1 by 3. Now substituting the value of a in expression of to get E minimum H. A minimum is equals to 5h cross square by 4m 1 by 4 h cross square by mg की power 2 by 3 plus 5 by 16 g 2 h cross square by mg की power 1 by 3 equals to 15 by 16 h square g square by m की power 1 by 3, or I would be writing it here 15 by 16 h square g square by m की power 1 by 3. Thus our correct option would be option A.